Alright guys, welcome back, and before we get into example 2, I'd just like to give a shout out to Chance, Emmanuel and Buchanan for making very good efforts in terms of answering the question that was given yesterday. So I just want to give a shout out to those 3 particular guys who did well in terms of the execution of the video. Except that the next time I ask you to do a video presentation, make sure that after you finish you turn the orientation of the video correct, because I think in Chan's case the video was posted upside down and it was difficult to interpret. In some cases also, when you're explaining, you made a couple of errors in terms of what you were saying, but that's okay. But you ended up with the correct answer in some cases. So the effort was good, so I just like to commend Chance, Emmanuel and Buchanan. Okay, now we're looking at our second example. We're asked to solve the pair of simultaneous equations using matrices method, and the 2 variables involved are t and u, and looking at them, they're not very organized really, so we have to take the approach of organizing these 2 equations before we begin. Alright, so what I'm going to do is I'm actually going to organize both equations in such a way where I'm going to have t at the front and u second, and then the numbers alone on the right hand side. So for equation 1, I'm going to have t there, alright, but what I'm going to do is move this positive u over. It's going to become negative u, and negative 7 is going to be left on the right hand side. So I'm finished with equation 1 in terms of organization. For this one, u is in front, but I want to get t in front. T is positive here, so I'm going to carry it over, so it's going to become negative t. I'm not moving the positive 2u, so that's going to remain positive 2u. And I'm going to take this negative 12 and carry it on the right hand side, so it's going to become positive 12. So essentially now, I have the equations, both equations organized where I have t's at the front, u second, and just numbers on the right hand side. So let's go. So now that I have that, I can it doesn't really matter what letter it is. I could call it C as well in terms of the matrix, a 2 by 2 matrix that we're going to generate. So let's C equals, and the coefficient of t here in equation 1 is positive 1. The coefficient of u here is negative 1. For equation 2, the coefficient of t here is negative 1. And the coefficient of u here is positive 2. So we're going to go ahead and attempt to find the determinant. I'm going to say, I was about to say A, but you know that we've called it C. It's typical of me. So I'm going to find the determinant of C, which is the product of the elements in the leading diagonal. So that will be 1 times 2 minus the product of the other 2 elements. Okay? So this is now going to be 2 minus, and minus 1 times minus 1 is positive 1. So 2 minus 1 is simply 1. So I found the determinant there. What I need to go ahead now and find is the adjoint of matrix C. So the adjoint of matrix C would simply be switching the position of the elements in the leading diagonal. So that would be 2 and 1. Leaving these 2 elements in the same position but changing the sign. So this would give us positive 1, positive 1. And then, of course, the inverse of C would be equal to 1 over the determinant of C times the adjoint, which we found. So this would be equal to 1 over 1, and 1 over 1 is just 1, times the adjoint. So if you take 1 and multiply by a matrix, you're simply going to get by that matrix 2, 1, 1, 1. And that is what the inverse is. So now that we found the inverse of the matrix, we can go ahead and generate the matrix setup to allow us to calculate the values of t and u. Now, remember, t came first in both equations and then u. So I'm going to write t u would be equal to the inverse of c times the numbers that are on the right hand side. And if you look close at numbers on the right hand side are negative 7 and 12. So I'm just going to put negative 7 here and 12, and then proceed to multiply the inverse, which is 2, 1, 1, 1, by negative 7 and 12, and we should get the values of t and u. So let's go ahead. So what we have here, 2 times negative 7 plus 1 times 12, 1 times negative 7 plus 1 times 12. So what we will have here is negative 14 plus 12, negative 7 plus 12. So we're close to the end of the working out for this question. Very, very, very simple. So what we'd have here is tu, and that will be equal to negative 14 plus 12 gives us negative 2, and negative 7 plus 12 gives us positive 5. And based on equal matrices, then therefore t will be equal to negative 2 and u will be equal to 5. As simple as that. And if you actually test it in the original equations, you would see it makes sense, because negative 2, which is the value of t, minus 5, negative 2 minus 5 would give you negative 7. The negative of negative 2 would be positive 2, and positive 2 plus 2 times 5, 2 times 5 is 10, and 10 plus positive 2 would give you positive 12. So it works out, right? So again, this was the original question. What I sought to do was to arrange it in such a way where I chose to put the t's at the front, so I reorganized both equations because both equations need reorganizing. So I wanted to have t at the front. You could have put u at the front, but if you had put u at the front, of course you'd have a u up here and then t down here. So depending on which one you put at the front, this would be adjusted. So I went ahead and then organized the equations where I had t at the front, u, and the numbers on the right hand side. Generated a matrix called C. It doesn't matter whether I use A, B, C, Z, whatever it is. Alright, so I generated a 2 by 2 matrix based on using the coefficients of t, of u, of t, and u here. And this is what we got. And then we found the determinant, which happens to be 1. Now, after finding the determinant, went ahead and found the adjoint of the matrix, which is this. And then went to use a formula to find the inverse of C, which is 1 over the determinant times the adjoint. And this is what we got. The inverse is 2, 1, 1, 1. Alright. Afterwards, we went ahead and used the formula that allows us to find the values of t and u. So it was the inverse times the numbers on the right hand side, and then we worked it out. Obviously, we would have gotten a 2 by 1 matrix for the answer because we're multiplying a 2 by 2 matrix by a 2 by 1. You know that rule already. Alright? And then eventually, we found the values of t and u based on the fact that we're applying equal matrices in this case. Alright? So gentlemen, I hope that officially we're at the end of matrices. As in pure matrices, because we'll encounter it at a later date in other areas. Alright? So I hope you found this video insightful, and I hope you found matrices interesting. So I'll see you guys on the next video.